Hello and welcome to Elect 121 Experiment M. So what you're going to see are the series of videos of each experiment, but let's talk about the equipment first. So this here is a standard DC power supply that we're going to use for the experiment. Let's talk about the layout here. So here we have the display for the voltage and the current. We have some terminals here. So these are color coded. So the red terminal here is the positive terminal, the black terminal here is the negative terminal, and the green one there is the ground or reference terminal, or otherwise called common. Now these colors, they are standard colors for the positive, negative and ground terminals. We also have the series of controls here to adjust the current and voltage. So this one here adjusts the voltage. As you can see, the voltage is going up to 13 volts there, and this adjusts the current. Now as you see, the current is 0 because there is no load attached to the terminal, so there's no flow of current. Now this unit has 3 power supplies in it. So this one here is channel 1. This one here, channel 2, is another separate power supply, and there's also a couple of terminals here for a third power supply. This one here, this is a fixed 5 volt supply, and we're not going to use that in the experiment. We're only going to use channel 2 and channel 1. We also need to set various modes. So here you can see the LED lit up as constant current mode. This essentially means that the unit's behaving as a ideal current source or constant current source. What this means is that the user sets the current, which is then maintained or kept constant. So even though I change the load, the unit will adjust the voltage to always maintain that constant current. So in order to set the constant current mode, what I need to do is maximize the voltage here, set this to the maximum voltage. That gives the unit the maximum range of voltage in order to maintain the current. And then I adjust the current to whatever value I require. There's also another mode, is CV mode. There's a little LED here for that will light up. This is the same thing. The unit then behaves like a voltage source, an ideal constant voltage source. So in that case, the voltage is set to the value that you require, and then the unit will adjust the current in order to maintain that voltage. And again, the same settings. So in order to set constant voltage mode, I need to maximize the current knob here to give the unit the maximum amount of range in order to maintain that voltage. So at the moment, see, we have 7.6 volts on the display, and the current is reading 0. That's because there is no load attached to the terminal. So that's the DC power supply. So what we're going to talk about next is the motor. Okay, so what we have here is the actual DC motor. So the actual motor itself is this top part here. You can see hopefully see the axle with a black and white disc on it. The black and white markings, when combined with an optical sensor, will enable the speed of the motor to be measured. Then we have this part here, which is the display. This inside here is an electronic circuit that essentially measures the magnetic field as well as the speed of the motor. So the top display here is the RPM, the revolution per minute. It's how fast the disc here, or how fast the motor is spinning. So this part here displays the magnetic field in units of millitesla. Even though it says Tesla, this display is actually in millitesla. This lower part here, as you can see, we have the field coil here with 3 connections, F1, F2 and F3. And we also have the armature part here with A1 and A2 terminals.